Welcome, everyone. In today's Call the Doctor, I'm going to talk about something called a MultiManager. This is a h5pyd feature that was recently added. It's interesting, it came up in the forum this week. We had a user who was using HSDS, and they had a situation where they have many, many small data sets. And when they tried to read each of these data sets in turn, overall, the performance was somewhat lacking. And this is a kind of an issue, I guess, for any kind of server-based software, because every time you go to read a data set, it's the client generates an HTTP request that goes to the server. The server may have to go to S3 to fetch the data and then return that. So there's a bit of latency for each operation. And then if you accumulate this over many, many data sets, for example, then overall your performance suffers compared to, say, using the HDF library and local storage. So to address this, there's a new feature called MultiManager. And the idea of MultiManager is that it allows you to read multiple data sets in one call. So maybe the syntax isn't as Pythonic as the normal thing, but the advantage is that rather than reading, say, n data sets one by one, h5pyd in this case would send n requests to read n selections from n data sets and then get results back. It also works the other way. You can do n writes to n datasets over n selections. Okay, so that sounds a little mysterious, but here is a notebook that shows you how this all works. So let me come here. Let me clear output. So start with, I should mention actually, there's a pending pull request to add an equivalent MultiManager to h5py. The internals of how it works are rather different, but it will have the same interface as the h5pyd MultiManager. But anyway, so we'll be in the HSDS case, and we'll import h5pyd as h5py, and then from h5pyd, import MultiManager. And now I will open a domain. I'll call it multitry.h5. And it's opening as write, so it's going to erase any existing domain, that name. And now let's try this out. So to make this a little more concise, I defined a dataset shape of 10, dataset D type of N32, dataset count of 4, and I just loop around for dataset count, and I create a dataset, and I append it to this list of datasets. Okay, in this case, the datasets are all the same group, and they all have the same shape, the same type, but none of that is actually a requirement to use the MultiManager. So let me do that. And I lost my mouse. Okay, so now we have, in this case, 4 new datasets. And coming down here, we're going to, for each of these data sets, we're going to create a list of numbers and then add it to this list of NumPy arrays. So data in is going to be, in the end, it'll be a list of 4 NumPy arrays, each with a integer sequence. Let me do that. And just to illustrate, if I say data in, say, 1, the second element of data in, we have 100, 101, 102, 103, so on. And data in 2 would be 200, 201, and data in 3 would be 300, and so on. Okay, so now we have our list of data sets, and we're going to instantiate MultiManager with this list. And data in, again, is our set of NumPy arrays. And I'm going to write each of these NumPy arrays to each of the data sets. So we have 4 data sets, we have 4 NumPy arrays, and it's a one-to-one injection there. There, we're done. So by contrast, normally I would do something like for I in 1 to 4, set data set 1 to data in 1, set data set 2, data in 2, and so on. But here it's just one call, bracket dot 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 bracket equals data in. And then if I look at this data set, so let's access data set 0 and read out all the values for it. We see it's 0, 1, 2, 3 to 9. And the second one will be 100, 101, 102, just like we saw before. Okay, so that was writing using MultiManager. We can also read using MultiManager. So MM is still our MultiManager instance, which is attached to these 4 data sets. And if I say bracket dot 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 bracket, that's just like syntax for a data set. If I said data set bracket dot 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 bracket, it's saying read all the data from the data set. Here, I'm saying read all the data for all the data sets in the MultiManager instance. So we do data out equals bracket dot dot dot. And we have 4 items. And each of these 4 items corresponds to one of those original NumPy arrays that we initially assigned to the datasets. Okay, so that's all pretty easy. You actually can also, you don't need to read all the data or write all the data. Here, I'm going to say, using our MultiManager, I'm going to read the first 4 elements of each of the 4 datasets. So I do that. Now I'm accessing the first of the output arrays, which is 0, 1, 2, 3. And if I did the 1, it would be the 100, 101, 102, 103. Okay. In all the cases till now, we've been applying the same selection to each of the data sets. But you can also have arbitrary selections. So here, I'm going to create a list of selections. So for each data set in our count, I'm going to find a slice of n to n plus 2 and add that to my list of selections. And then I'm going to say dot get item print selections. Okay, so now the first item has the first 2 elements from the first data set. The second item has elements 1 and 2 from the second data set. And if I did the last 2, it would be elements 3 and 4 from the third data set. And the fourth output would be elements 4 and 5 from the fourth data set, if I have that right. Okay, so that all seems very interesting, I guess. But how does it really help in terms of performance? Well, there's another. Oh, I should say that all this code is in h5pyd. So if you go to github.com/HDF Group/h5pyd, you'll find it here under examples. So examples, MultiManager benchmark.py. What we do is we create a file, and then I initialize a bunch of data sets, and I try reading these data sets sequentially and then read them of the MultiManager. So the sequential would just go over this list, and for each of these indices, it would do a dataset bracket index. And then it runs it several times and then average out all the runtimes and reports that. And the MultiManager version creates a MultiManager instance of our data sets and uses bracket query to do the same thing. And it's using these initial values, 200 data sets, data set shape of 10, and data set D type of 4-byte integer. So you're free to change these to different things and maybe more match your application and see how the performance works. So let me just try running this here. So I'm here in the terminal window. If I say Python MultiManager benchmark, so it takes a bit time to run. Okay, so the sequential runtime was 1.08 seconds, and the multi-manager runtime was 0.25. So about a 4x improvement versus the sequential code. So that's pretty good. And then incidentally, that is what our forum poster saw when he got this code and tried it himself. So this is actually running on my notebook, and I'm accessing data on an SSD drive. So we can also try this with S3. So let me switch to a different machine. h5pyd. Now I'm connected to an EC2 instance on AWS. And we have the same code here. And if I run this, so the thing about accessing S3 is that compared to the previous example, you have not only latency of going from your client to HSDS, but also many times from HSDS to S3 storage. So that can increase the latency per request. And therefore, it's very typical. You'll see better speed up because you are amortizing the increased latency to access S3 by having more in-flight S3 requests at any one time. Let's see. Okay, so the sequential runtime was 3.2 seconds, and the multi-manager runtime was 0.46. So more than a 6x speed up in this case. Okay, so I hope people get a chance to try this out. I'd be interested to see what kind of increased performance they get, if any, with this. But hopefully it'll be helpful for some people. Anyway, so that's all I have to talk about MultiManager. Any questions about the MultiManager?
John, is the multi-manager have any parameterizable settings?
No, it doesn't. So other than, how many data sets you connect to it and the type of selections you have.
Okay.
Hi, John. It's Ray here. Good to talk to you again.
Great.
So I missed the very beginning, I'm afraid.
Okay.
Did you can you specify the path within the file in the multi-manager? Can these data sets go into different locations within the file?
Yeah, they can be, the data sets can be in different locations. They can actually be in different files, right? And
Okay.
like I was saying, that you can have different selections for each of the data sets. But in any case, it's the same idea is that you are multiplexing these requests. So rather than one by one, you have multiple in-flight requests going to S3. We've actually done something very similar with attributes for a long time, because when you open a domain, by default, when you first get the response, you also get all the attributes for all the objects of that domain. And internally, how it works is that we have multiple requests going to S3 to fetch the metadata for that. So it's much faster than if you had to iterate through each group and data set, and for each group data set, get all the attributes. But here, it's since data sets can be quite large, it's something that has to be kind of handled on the user side.
So if you're writing a very large data set, are there advantages I mean, if you were to run this in, say, parallelized code, are there advantages in splitting the data set up into more chunks and running the multi-manager rather than just doing it directly, writing a single data set directly?
I would think it'd be likely not to be a big increase in performance, right? And there is some overhead because internally how the multi-manager works is using Python multi-threading.
Right.
So many of you know that in Python, you don't have true multi-threading. There's this thing called the GIL that basically blocks multiple Python threads from running simultaneously. But at the point in Python where we actually send the HTTP request out, that releases a GIL. So Python is free to switch to a different thread at that point. And that's how we gain the advantage of using multi-threading, even though Python doesn't have true multi-threading. If you're using like multi-processing to parallelize some kind of work job, that probably would work slightly better, have less overhead. One thing with the multi-manager is, and actually the forum poster pointed this out as well, that say I'm reading 5 data sets and one is quite large and the others are fairly small, you won't return until that largest data set read is done. So that's kind of wasting, if you will, some of your time because you can't continue until the last guy is done. But I think the big benefit here, I feel, is that compared to some other techniques, for example, async IO is one, are explicitly using multi-threading in the application code. This is quite simple in terms of the application logic, right? You don't need to change the structure of your app. You just do as before, but you're doing multiple things at once. All right. If there's no other questions about the multi-manager, if anyone has any questions at all, I'll be happy to hear them.
John, I had one other question on the multi-manager,
Yeah.
but it's not exactly a Python question.
Okay.
If you were using a native code API to the RESTful, and you wanted functionality like this, at that point you would be responsible for rolling your own native code in a way that mimics.
Well, no, not exactly.
Okay.
So, and that actually is the point I probably should explain. So in recent HDF5 library releases, there's been a new function called the h5d read multi and a corresponding function h5d write multi. And that function works sort of like the multi-manager works in that you give it a list of data sets and selections, and it processes that as one fall. Okay, so, and this was released starting 1.14, I believe. And the thing though is that it only provides a performance enhancement if you're running parallel HDF. If you're running the regular library internally, the H5D read and write multi just revert to a loop, right? Reading each of those selections one by one. So it's just the same as if you had done it in the client code. But then for the RESTful, we implemented a version of H5D read write multi specific for HSDS, where that does do parallel requests to HSDS. So if you have C code using the RESTful and you use this H5D read write multi, you should get similar speedups or even better speedups than what we're seeing here with the MultiManager.
I see. Okay, thank you very much for that clarification. I was not aware of what had been done on the RESTful side from native code. That's excellent. Okay, that straightens me out. I appreciate that. Thank you.
And thank you for reminding me to bring that up. I'm just curious, have you heard of the H5D read multi functions before?
No, this was new to me. I haven't quite gotten there in my studies yet. I haven't had a need to uncover that.
Right.
So I appreciate the explanation.
Right. Okay. Well, thank you. Well, last chance for questions. Okay. If not, thanks everyone for their time today, and we'll catch you next time.